Hello everyone, today I'm gonna present my WAN project. Okay, computer networks, connection of two or more computers by some type of medium. Devices exchange data and the connection must be established. And by connecting devices through networks, users can access information, share files, maybe data, also communicate with each other in an efficient way. Network diagram. And this is a network diagram was set up. This is like LAN because we bounded to switch this, and this is WAN connection because router bounded to the internet, and the other LANs connected to router. This is a type of medium wired way. This is a type of wireless way, and each devices uh, must be present in the connection at the network. LAN, types of networks. This is a representation of LAN, or this is a other LAN, and connection to the LANs to LAN. It indicates it's a WAN. Let's suppose this device is a connects to this device. It's a source device and it's a destination device. And the source device sent to the packet to gateway, and this gateway it's a actually router. Router forwards to the packet the other routers, and this router forwards to the packet to the destination. And this is a communication way like that. We can solve that previously page in the LAN. Local area network is a collection of devices with a small number of small geographical area, and this is a connection topology star. Well, wide array network, we saw that in the types of networks. It's a wide array network is a collection of LANs actually, and ones are requires a router, and one is actually networks of networks. The internet, it's a example of the WAN. Types of networks, we will see physical addresses. Physical addresses, it's a hardware address. It's also known MAC address. And MAC addresses are identify devices on a local area. And this is a representation of MAC address. Logical addresses, and IP is a logical address actually. When we want to connect the internet, we have IP we need have IP address, and this IP address actually ones and zeros, because this is a represented way to we visualize that. And it's a unique address. It's my project. We want to connect two buildings, and these buildings are contains some departments, like as you see, and 100 employees, and we want to connect in the company network to the internet, and that's why we need the ISP routers, and each department we will be another broadcast. That means that this is a VLAN, and we want to look. We want to catch any traffic packet to the other VLANs, and this is requirements for to do that, and we need to build a secure network topology because the organization requirements it's to secure, and we need to have a core routers, a multi-layer switches, and access switches to establish that, and VLANs we say that, and DHCP service to allocation IP assignments, and we need the routing protocol to do router to router communication, which is the layer 3 communication. To do that, we have OSPF, which is the open short path first, means that, and furthermore, we need to establish VPN tunnel, and so on. This is test ways, ping, and traceroute commands. And this is the network topology. This is our network topology. If you see that this is departments, this is departments, this is departments, and this is the building one, and the building, this is maybe a headquarter. This is the branch, and these buildings wants to connect to each other. And when we do that, we need to connect to these core routers to each other, and these core routers connected to ISPs. And when this user or this device connect to internet, this needs to connect to these devices, and this router IP address of this device was actually private IP address, and this router translated by the public IP address, which is the ISP connection. And let's see something for to do that, and we have Cisco packet tracer environment, and I want to show that, and this is the first attempt to do establish to this network, and I want to show that because these connections are red, this is down connections, and if you don't do any if we don't implement any protocol or configuration, we will not connect each other through this network. And we will see this is the connection test for the packet tracer. You can see this is a failed. The ICMP packet, which is the ping protocol, let's say, this is the failed one, and Let's close that, and I want to show the actual project. Sorry for the convenience. And the DHCP server actually will give IP address to these devices because we have many devices. We can't do that manual way, and this is not possible for the maybe 1,000 device. And we will say that this is our actual project. You can see these connections are green. Everything was set up, and um, we can show that is like that. Sorry, and okay. First of all, we need to activate these router ports. This is essential. And the other one, to do that, we need to configure these network devices, switches, multi-layer switches, and routers to basic configurations. And let me show that any of that. And okay, if we type show running config, uh, let's say the hostname swcs. Okay, this one like that, and this is our banner message. This is the basic configuration. All other switches remains uh, same except host names. Okay, SSH configuration is actually remote connection. I will show that any of the devices, and I will try to do that. And for SSHL, and for the communicate any device, we want to IP address of the device. This is IP address of the device is like, and I want to type my username is admin, and my IP address of this layer 3 switch 10.10.5, and my password, and and I'm connected this device, and I, you can see hostname. And secure shell, it's a remote connection protocol, and I'm configured the devices. And VLANs assignments, we can say that show VLAN brief, and as you see I'm at laptop, and actually I'm at layer 3 switches because I'm monitoring that device's configuration, and you can see this is our ports and this is my VLANs, and when we say, you can see VLANs, and the other devices remains the same. And actually these ports changeable because these ports are trunks, and these ports are trunk. These ports are actually access ports, like that. Okay, show interface, and we say strong, and we can see these ports, these and okay, these ones, all of that ports and trunks. You can see encapsulation .1 q. Okay, and this is configurations and seems because the other devices remain same, but these ports or this this VLANs changeable because not the same VLANs as you see. It's a VLAN 20, VLAN 70, and we configure it like requirements like that. And we uh, we have a server room, you know, and this server room we want to avoid vulnerability, and we have secure communication. We want to secure, uh, and we mm, we used switch port security. And subnetting and IP addressing, we need to assign an IP address to the layer 3 interface. Layer 3 interface means that when we uh, when we implement any routing protocols, we will need any IP address to do that. Let's see. This is a multi-layer switch, and these ports have an IP address. And uh, we we did that for with no switch port because this is a multi-layer switch. Okay, we configured the other multi-layer switches like that. And IP addressing of the routers, same. We choose IP addresses, and we we type IP addresses to the interfaces like this interface serial 00. Let's show that again. Let's see serial 00 IP address 1.1 10.1 like that. This is our IP addresses. Each of the IP addresses, as you see, sorry, as you see, and this is our IP addresses, router is, and this is ISPs, IP addresses, as you see, and we have OSPF configuration. We can configure any routing protocol. I want to choose OSPF, and to configure OSPF, we have to check how many connected networks because we advertise these networks. And as you see, we advertise networks. This is the networks. As you see, these are matching. And we need to IP route 0.0.0 because 0.0 means that whenever there is no matching to this table, you will go to the next hop. Next hop means that next hop means that like this switch next hops routers. Okay, and as we show this OSPF configurations, as you see, show show IP OSPF neighbor, and as you see, the routers neighbors are like that. And this is the same because the other ones connected to other IPs and so on. And DHCP, we gave static IP address to server room, but we will give IP addresses all of these devices dynamically. And to do that, the responsible DHCP server. And when we show that, we want to we we need to this all of the departments must be full, and we define default gateways, starting IP address, subnet mask, and the DHCP server pools must be like that. And the other ones like that. Okay, when we defined pools, we need to do something extra. We need to say these switches, this DHCP server's IP address. This means that helper address to DHCP server, and all of the interfaces and the other switches or these switches, we advertise IP helper address, all of that, because and any devices connected to this device. And for to do that, we gave we need to try something about desktop and IP configuration. Let's say choose static and choose DHCP. We requesting IP address, and this request successful. When it's a new IP address, and all of that, this configuration process takes to. And this is a wireless network configurations. Any access point configuration like that, SSID name and password phrase. And when we connect to the access point, we will connect to the we connected to networks. As you see, DHCP server will be gave an IP address to this device to through the wirelessly. Wireless configurations like that, and NAT network address translation. We need to configure NAT on the core routers, and private. As we know, this one's private IP address, and when we want to connect internet, we need to translate this IP address to public IP address, and we configure network address configuration, and this configurations like that. This is not outside ports. This is not inside ports, and we created access list to permit all of the networks, and the same of this site. And when we try to not we we need to pinging this ISP router and select any of the device. Okay, we will ping what's my IP, and my IP is 15.7 and ping ISP router. I'm pinging and this ping indicates that all of the ICMP packets are successful. Now I want to show my translated IP address. Show IP not translations. This is okay. This is, as you remember, this is my private IP address. This is my private IP address, and this is the my translated address. Inside global is my public IP address to the access this. And we configured, I configured site-to-site VPN, and this is needed to create a tunnel, and we enable security license for to do that, and we 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 did that for route summarization for to do that, and we created access control list, and as you see, sorry, we summarizes we have summarized this IP address to this IP address because we have 5 networks, and we have each of the 5 networks 5 routes. This means that in the access control list we want we give 25 list, and to do I didn't do that. I will sorry, I was expected to the route to summarize it, and I did that to do this like that. This is my permit IP addresses, access control list, and when we show that site-to-site VPN encrypts, we can show that like that. I'm choosing any of the device, and I'm copying this IP address and choose other of the device and pinging to site. And sometimes its first packet may be dropped and the other packets will be gone. And try again. Okay, my packets are going to other site, and when we say show crypto IPsec security association, you can see that sorry about that. You can see this is my VPN map, local addresses. The packets encapsulation was successful. The encapsulations are successfully. This means that if I'm pinging to this site, to this site, this site, to this site, this tunnel encrypts all of the traffics, and this is the this is the any efficient way to do that. Pinging, it's an example of that. The sorry, sometimes to do that, and to do that, I'm pinging to VLAN to VLAN. This is a test for do that, and sometimes this requires some things. Sorry, I'm testing the others one. I'm choosing this one, and I'm copying this IP address, and of the device or to do that. And I want to show something. Sorry about that. This is IP. This will be IP address. And first packet was maybe dropped, will be dropped, but the other packets will be gone. And this means that I'm gonna I'm reach it to this site we can say. This company user can share information to this site because you see this ping was successful. And tracer comment is it's a other comments of the like ping. And when we say I want to access this layer 3 switch ports, we say that tracer dot sorry, and when we do that, okay, this is the hops. This hop means that routers. This device first first this device packets first go to this switch. This is a default gateway, and the connect to this device or this device. The switch prefer this way because, as you see, this is a IP address of that, and this router forwarded the packet to router, and this router forwarded packet this switch, and all of that done. And thank you for listening. Thank you for listening.